So on this problem, what we should do is take the function f of x and just state everything that we can about f of x, of that equation, of that quadratic equation, and then afterwards look and see if we could find any of the true statements. So of course we're going to begin with the vertex. The vertex is a coordinate. It's really an x value and a y value, okay? And the way to find that x value is to use the formula x equals negative b over 2 times a. And when you use the formula, it'd be a great idea to use parentheses instead of your b's and a's. Now, where are we going to get those b's and a's from? The standard form quadratic equation. The a value is negative 1, the b value is 6, and the c value is negative 15, which is not even in the formula. So the b value of 6 goes right in the parenthesis. The a value of negative 1 goes down there. And what do we have here? We have a negative 6 over negative 2. So x really does equal positive 3. Okay? And this is the x of the vertex. Whenever you have an x and you want a y, all you have to do is plug it back into the original equation. So here's my original equation. I just rewrote it. And I put parentheses in place of the x's. And the reason for that is because I know what x is. X is 3. So I'm going to take this value of 3 for x and replace the x's with them. So I'm going to put those 3's inside those parentheses. And now we're going to simplify this math. But be very careful because this does not say negative 3 squared. See, students sometimes think, oh, negative 3 to the second power, that's positive 9. That's wrong. Because this negative out in front is really like a negative 1 that's being multiplied by whatever answer you get here. And of course, you need to do exponents before multiplication of negative 1. So you need to deal with the exponent first. That's 3 squared. That will be a 9. But don't forget that this minus sign has to be out in front. So that's really a negative 9. And over here, the 6 times 3, that is a 18. And it's positive, put a plus sign in front of it. And the minus 15 at the very end, you just bring it down. And now we have these 3 numbers that we need to add and subtract. So from left to right, negative 9 plus 18, that is a positive 9. Positive 9, take away 15, that is a negative 6. So the vertex y value is negative 6. Once again, just to reiterate, we use the formula x to be able to get the answer x of the vertex, which is 3, which is right there. And then we took the x and plugged it in, and then we got the y value equaling that answer, negative 6, which is right there. And now we have the vertex. That's the most important point right here. The vertex is the most important point. So what else could we say about this vertex, or from this vertex? We could state numerous things. You know what? I think we should pause right there with the work, and let's take a look at what true statements there are. Okay, so they're saying that the vertex is 3, 11. Yeah, the vertex is 3, but not 11. It's negative 6. So this one for sure do not select. The vertex is not 3, 11. It's 3, negative 6. Let's talk this next one, the transformations. The transformation from the parent graph to f of x is a reflection across the x-axis. So let's look at the original. Does it reflect over the x-axis? Yes. The negative sign implies a reflection over the x-axis. Now notice that there's a 1 right here. If there were a 2, it would be a vertical stretch by a factor of 2. If there were a 3, a vertical stretch by a factor of 3. If it would be like a 1/2, that'd be a vertical compression by a factor of 1/2. So it's a 1, so it doesn't get vertically stretched nor compressed. So the only thing that happens is that it gets reflected over the x-axis, and then normally you look at your vertex form equation h and k, and the h is the shift left and right, and the k is the shift up and down. But as you could see, we don't have an h and k. We have a standard form that's ax squared plus bx plus c. But we found the vertex, and we should all know that the vertex really is an h and a k value. So we really do know the h and k, all right? Let's just show this. Let's draw a quick sketch here so you could see it visually. 3 on the x, 1, 2, 3, negative 6 on the y. Here is my coordinate. This thing is opening down with the pattern 1, 1, 2, 4, 3, 9. So, I mean, it's just a sketch. So 1, 1, 2, 4, and 3, 9 would be further down. Map it over to the other side. It would be like that. So anyways, this is just a sketch. And from the original parent graph that had the vertex here that was opening up, we said that it gets reflected. So now it's opening down. And then what do we need to do? We need to shift. Where do we need to shift? We need to shift over here and down here. So that would be 3 to the right and 6 down. So let's read the transformations again. The transformation of the parent graph from f of x is a reflection across the x-axis and then also shifts 3 to the left. Does it shift 3 to the left and 6 down? No, it doesn't. It shifts 3 to the right and 6 down. So you got to be very, very careful with this one because, and believe me, I've made a mistake on this one in the past. It says shifts 3 to the left, and that's incorrect. That should have read 3 to the right. I mean, think about it. From the origin, the parent graph, it has to get to that vertex. It's 3 to the right and 6 down. Anyway, so that makes this thing false. So don't pick that one either. So far, nothing's been true. Axis of symmetry, that's an easy one. It's simply, the axis of symmetry will be x equals the x value of your vertex, which is 3. X equals 3, that's the axis of symmetry. Now, is this axis of symmetry, is x equals -3? We know it should be +3, so that's not it either. Man, nothing's been true so far. Let's move over here. How about over here, the range? Range. Well, I could think about it visually. My range, it's either up or down. It's either at or above this y value or at or below this y value. Obviously, the parabola is opening down, and we know that the vertex is 3, -6. So -6 is your y value. That's technically your maximum value. Your maximum value is the y value of -6, and it's at that -6 and below. So how do I say at and below in terms of range? You're going to say y is less than or equal to -6. So let's verify. Does it say y is less than or equal to -6? Nope, it does not. So that's not it either. The maximum value is -6. Finally, we actually have a true statement, right? Remember, the vertex is your maximum or minimum, depending on if it opens up or down. And if you did this sketch, you'll be able to see that it goes up, 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 and it reaches a maximum height, and then it goes back down. So down here, you're like at -12, and then it goes up to -5. It reaches, not -5, it reaches a total of -6. That's the maximum height in terms of y. Remember, y's are opening up and down, or running up and down. So in terms of y's, the y values keep getting bigger and bigger and bigger, and then it reaches the maximum height on the y's, which is a -6, and then it goes back down. So this is the only true statement that the maximum value is -6. Hopefully we could find more true statements and other problems, but on this one, this is the only one that's true. Everything else is incorrect.